You've done it. I've done it. We've all grabbed our phone and typed in coffee near me. But have you ever actually stopped to wonder how your phone pulls that off? I mean, how does it really solve that puzzle? Well, we're going to pull back the curtain on the hidden tech behind that simple, everyday search.
On the surface, it seems so easy, right? You ask a question, and boom, a perfect list of cafes just appears, all sorted by how close they are. But behind that smooth, seamless experience is a really fascinating and surprisingly tough technical problem that engineers have been chipping away at for decades.
And that's because, for a computer, the whole idea of near is not easy at all. In fact, for a long time, this was a massive head-scratcher for anyone trying to build an app that knew anything about location. So, what makes it so difficult?
Okay, so think about a normal database. It is fantastic at searching in one dimension. Like looking up a name in a phone book by just going down a single list, from A to Z. Easy. But our world isn't a single list. It's two-dimensional, right? It has latitude and longitude. A regular database just gets totally confused. It can't easily look at both of those numbers at the same time to figure out what close even means. It's kind of like trying to find a city on a map by only looking at the page numbers. You're just completely missing a whole dimension of information.
So, how in the world did we fix this? Well, it took a totally new way of thinking about the problem. It was a real aha moment that led to a new kind of digital map, one that was built from the ground up just to understand space. And that solution is a concept called Geo-Spatial Indexing. You see, the real trick isn't just about storing location data. It's about storing it in a way that actually preserves the relationships between places. That right there, that's the magic that makes a near-me search not just possible, but lightning fast. But, like with any big tech problem, there's never just one solution. There are a few really brilliant ways to do this, and each one has its own unique strategy for mapping out the world. So let's meet the main contenders in this race.
First up to the plate, we have something called the R tree. Now, the R stands for rectangle, and that gives you a massive clue about how this thing works.
So the idea is kind of like organizing a messy closet. You put all the little things into small boxes, and then you put those small boxes into bigger ones. An R tree does the exact same thing with locations on a map. It groups nearby coffee shops and restaurants into these imaginary rectangles. So when you search for coffee near me, the system doesn't have to check every single cafe in the city. Nope, it just looks inside the big boxes that are in your general area and then the smaller boxes inside those. It's just incredibly efficient.
All right, next up, we have the geohash. And this one takes a completely different, and you could say a more elegant approach to the whole problem.
The absolute genius of geohash is that it takes two numbers, your latitude and your longitude, and it squishes them together into a single string of letters and numbers. You can think of it like a super precise global zip code. And here's the cool part. Locations that are physically close to each other end up with almost identical codes, see? To find what's nearby, the computer just has to look for other codes that start with the same characters. It's such a simple and beautiful idea.
And finally, we have the heavyweight contender. This one comes from Google, and it's a system called the S2 library. This is the beast of an engine running behind the scenes on things like Google Maps, which, billions of us use every single day.
Now this one's a little bit of a mind bender, so stick with me here. Imagine taking our round Earth and putting it inside a giant cube. Got it? Okay. Now, imagine shining a light from the center of the Earth and projecting every single point on the globe onto the flat sides of that cube. You then divide those flat sides into a grid of tiny cells. Each cell gets its own unique ID, and, just like with geohash, places that are near each other get similar IDs. It's a really complex solution for sure, but it's incredibly powerful when you have to map the entire planet. Okay, so we've got our three brilliant methods: R trees, geohash, and S2. But which one is actually the best? Let's put them head to head and see how they really stack up. So here's the breakdown. R trees of the specialists, right? They're amazing for handling complex shapes, like, say, the exact border of a city. That's why you see them in heavy-duty databases like Postgres. The downside, they can really eat up a lot of memory. Then you've got geohash. It's the simple, super fast one, but it can get a little bit weird right at the edges of its grid cells sometimes. And then there's S2, the powerhouse. It's definitely more complex to set up, but Google built it to handle the whole globe without even breaking a sweat, even in tricky spots like the North and South Poles.
So, which one wins? Well, the answer is, it depends. There is no single best method. It really just comes down to picking the right tool from the toolbox for the exact job you're trying to do.
So why should you care about any of this? Well, because whether you realize it or not, these abstract, invisible digital maps are pretty much running your life.
I mean, just think about it for a second. That food delivery app finding the closest driver, that ride-sharing app getting a car to you in minutes, that social media app tagging your photo to the exact spot you took it. All of them, every single one, is relying on one of these incredibly clever indexing methods. It's the invisible scaffolding holding up our modern, location-based world.
So, today we peeled back just one layer behind one simple search for coffee near me, and we found this entire hidden map that organizes our physical world. And that really leaves you with a bigger question, doesn't it? What other invisible systems are out there, shaping your digital life in ways you haven't even thought to ask about yet?